Hello everyone, in this math we will uh, calculate back of Q, of a shock wave, and also calculate duration for the Q duration. We will also calculate Q duration and Q length in this math. So this is a problem of shock wave theory. So to do this problem, firstly our capacity is given of the roadway. The capacity is given 4,000 vehicle per hour. The optimum operating speed, operating speed is 100 mile per hour, and a scenario is considered where demand is 3,000 vehicle per hour and drops to 2,000 vehicle per hour due to sudden stoppage or blocking by a vehicle, and the vehicle removes after 30 minutes. Our jam density is given. The value of jam density is 367 vehicle per mile. It is given. So we have to calculate firstly three things we have to calculate. Firstly, we have to calculate the speed of back of Q, that is we have to calculate the shock wave speed. Next we have to calculate duration of the Q, and lastly we have to calculate how far Q reaches. This will give the Q length. And to do this problem, firstly one thing we have to do is we have to draw the fundamental diagram based on the information. In the y-axis we have Q, x-axis we have K, that is density. Our fundamental diagram will be look like this. So for 4,000, that is peak capacity 4,000, we have value C, and jam density is 367. For corresponding density at 4,000, we have to calculate this value. Our operating speed is 100. So we know that and there is two situation. One is at A, our demand is 3,000, and at B our demand reduced to 2,000. So firstly we have to calculate the slope. Our operating speed is 100. The value will be given. Operating speed is 100. So we can calculate. We know that a Q equal to KV. So V equal to so the slope is so our operating speed is 100. So Q equal to V equal to Q by K. Q is 4,000. We do not know the K value. Our V is given 40 mile per hour. This value will be given 40 mile per hour. The slope is given 40. So actually here is this value should be actually 40 mile per hour is given. So our K, optimum K corresponding to 4,000 will be 100. So here K is 100. So we have to write the K value is 100 vehicle per mile. Next we have to calculate Ka and Kb. So before calculate the Ka and Kb, let's calculate for congested part. For congested part, V equal to our V, that is shockwave is, we have to know the V, our slope of the congested part is that Q by K. K value is 100, K value is 365 minus 100, and Q value is, we know that the up to 4000. So if we divide 4000 by 267, we will get around 15, this value. Say recalculate it, 4000 divided by 267 give us almost 15. So 15 is the slope in the congested part. So we get the two slope. Now we can calculate the value of, so we have to calculate at A our demand that is Q is 3000, and we have to calculate the density. We know the speed here, so our density at A, that is Ka, will be Q by V. So here our speed is 40 and demand is 3000. So 3000 divided by 40 give us 75. So we know that A point is 3075. Similarly, we have to calculate for B. To calculate for B, the Kb will be, total jam density is 367 minus to 367 is the total jam density, minus we have to subtract this part only, then we can calculate the value of Kb. So it is 2000, our value of demand is 2000 and slope is 15. So subtracting this value, we can get 233.7 vehicle per mile. So this will be Kb. So for B, our coordinate will be 2000 and 233.7. So now we can calculate shockwave speed, that is back of Q. Back of Q will be UAB, which will be QA minus QB divided by, if we want positive value, it will be KB minus KA. So our QA is 3000 here, QB is 2000, KB is 233.7 and Ka is 75. Calculating this give us 6.3 mile per hour. This will be the back of Q. So now let's draw in that time space trajectory what happened to this. If we consider y-axis, that is mile, and x-axis, that is time in hour, so the value, the shockwave speed will be A to B. A to B, it will be 6.3, the slope will be 6.3, and it is saying that after 30 minutes Q will disappear. So this time will be 0.5, and after some time Q will start to disappear and it will completely disseminate after some time, and say at the time Q will start to reduce, it will be T1. So we have to actually, we know that the shockwave speed, because after half an hour this slope is 15, and when Q fully dissipate the slope is 40, that is 40 mile per hour. We have already calculated in the very beginning. So it is actually optimum operating speed is 40 mile per hour, we know. So the length of the Q will be D. So let's calculate. We know that the 6.3 into T1 will give us the value of D, and 15 into T1 minus 0.5 will also give us the value of d. So we do not need to calculate the d value right now. If we calculate 6.3 T1, 15 T1 minus 7.5, so we can calculate the T1, that is 0.86 hour. So after 8.86 hour, the Q will start to dissipate, and the length of Q will be d. It will be 6.3 into T1, or we can calculate from here also. 6.3 into 0.86 will give us 5.4 miles. So maximum length of the Q will be 5.4 mile, and back of Q will be 6.3 mile per hour, and its duration is 0.86 hour. So we have three answers. One is speed of back of Q, one is duration of Q, and last one is our length of Q, that is how far the Q reaches. So using this we can calculate the whole thing. Thank you so much. Hope you understand the whole math. This is the math based on shockwave.